Okay, this is an application problem from the product and quotient rule section. It's number 59, and let me read it to you. It says a population of bacteria is introduced into a culture. The number of bacteria P can be modeled by this formula, okay, where T is the time in hours. Okay, so basically we have bacteria growing in some kind of a culture. If you tell me how many hours it's been growing, which is T, I can tell you the population number of bacterial cells in this culture. Okay. So what they ask for is find the rate of change of the population when T is equal to 2. Okay. So by now, the word rate of change, or the phrase rate of change, should be synonymous in your head with computer derivative. So this function, we can actually call it P of T. To me, it's always helpful to think of it as a function. They want us to find the derivative of this function, okay? And then they're going to have us compute the value of the derivative when T is equal to 2. So first thing, we just have to find the derivative itself. So I take the derivative with respect to T of this whole function, 500 times 1 plus 4T over 50 plus T squared. Okay. Now you've got a couple of options in the way you tackle a bigger function like this, but just use the rules we have. Okay, so first of all, the 500. Everything inside here is being multiplied by 500, right? So we can actually factor that 500 outside. Okay, so I can write this as 500 times the derivative of, 1 plus 4t over 50 plus t squared. Okay. See what I did there? I just factored this constant out using the constant multiple rule. Okay. So I'll keep going from there. Okay. What else can I do? Well, 500 is still here, but now I have the derivative of two terms, 1 plus something more complicated. So that 500 I have outside needs to be multiplied by the derivative of 1 plus the derivative of 4t over 50 plus t squared. Okay. So look at what I did there. All I've really done is use the sum rule, in this case, to separate into two derivatives. Okay. Now, I've got the small board here. You can come, you can see it closely, hopefully, on YouTube, but I am limited with space, so I'm going to have to erase some stuff here. So we're kind of in the middle of this derivative calculation. Let me clear out a little bit more room up here. Okay. The great news is you can always rewind it if you need to see something that I've erased. Okay, but well, what's next? Well, now we've got some derivatives we can compute. So the next thing I'll write is 500 times, well, what is the derivative of 1? Okay, the variable is t, but the derivative with respect to any variable of a constant is always 0. Okay. Now, to that I have to take the derivative. I have to add the derivative of this function, and that's kind of the tie-in with the new section. That's going to require the quotient rule. The function is 4t divided by 50 plus t squared. Okay. So I guess I should probably kind of keep it there, but you remind ourselves of the quotient rule. It says in our book, take the denominator, 50 plus t squared, times the derivative of the numerator. Okay, well, the derivative of 4t is just going to be 4. Okay. All right, it's just a constant times t, and the derivative of t is 1. Okay. Now from that we have to subtract the numerator times the derivative of the denominator. So 4t times the derivative of 50 plus t squared. Well, the derivative of 50 is 0. The derivative of t squared is going to be 2t, and that's it. Okay. And then in the denominator I've got the original denominator squared. Okay. Okay, so now I can finally erase this line and give myself even some more space. Okay. So basically what I've got here is 500 times whatever this fraction simplifies. That derivative was 0, so I can just wipe it away. Okay, what do I have here? Well, I need to simplify the numerator. That's going to be 200 plus 4t squared minus 8t squared all over 50 plus t squared squared. Okay. So I can write this as 500 times, and I can simplify this a little bit, 200 minus 4t squared all over 50 plus t squared squared. Okay, so hopefully you can see that okay. And by the way, there's no reason to square this thing, because I would actually have to FOIL 2 copies of 50 plus t squared. There's no reason to do that. Also, there's really no reason to multiply the 500 inside. Okay, so that's the derivative. It's sort of the part A in this calculation. It's really most of the work. Okay, so what is this thing that we found? This is P prime of T. Okay, this gives us the rate of change of this bacteria population. Okay, now we need to put the value of T that they ask us to put in. Okay, and in the problem they said find the rate of change of the population when T is equal to 2. Okay, so what they want here is P prime of 2. Okay, so I've got to take this whole expression and plug 2 in for T. Okay, and of course that's a little bit of typing on the calculator, but let's see. Okay. Well, when I compute this, I am getting, let's say, about 31.6. Okay, so what does that mean? Okay, well, it's the rate of change of the population of this bacteria. So we can actually interpret this that after 2 hours, okay, because we're computing the rate of change at 2 hours, okay, how fast is this bacterial population growing? So we can say the population is growing 31.6 cells per hour. Okay, we're talking about bacteria, so that's the number of bacterial cells, that's the rate of change of the bacterial cells. And it's growing at this rate per hour because those are the units of T.